Right. Hi. Thank you for that introduction. My name is Ben Tallman. I'm the CTO of M Science. I've been here for a little over 3 years now. I really want to thank Tom and Ascend for giving me this opportunity to give a quick talk about data at scale and the challenges and opportunities that face our business, M Science. And we're talking today about part of our data, 2.5 petabytes, give or take, and 60 billion rows, and the challenges we have in ingesting, tagging, analyzing, and delivering that data.
Cool. Well, thanks for joining us, Ben. Actually, this is, I know you live this story, so it probably doesn't seem sometimes all that exciting, except for the scale, but to others and to us, super interesting what you guys have going on there.
Yeah, thanks. Little technical difficulty there. Okay. We're going to talk, go through some quick introductions, a little bit more about us, business drivers, architecture, how we're solving the problem and looking forward. And as an introduction, just what M Science does, I've really boiled it down over the last 3 years to a fairly concise statement. We buy and procure alternative data. We ingest that data, tag the data, and leverage that data to predict public company revenues during the current quarter. Then we sell those predictions to hedge funds. Obviously, we're a bigger company than that, and we do a lot of other things. But if you really want to boil it down to a concise thing, that's it. We ingest data, we process that data, we use that data and our knowledge to predict public company revenues, and we sell those predictions to hedge funds and other companies. It's fair. It sounds simple, but remember, 2.5 petabytes of data and 60 billion records, that's 35–40% of our data across what we do. So it is more complex, and there's a lot of magic behind the scenes. In the end, though, that is truly what we do as a business. And what we're trying to accomplish specifically with Snowflake and with Ascend in this data set is to reduce our time to market. And I don't mean that it takes 6 weeks or a year to build a product and bring it to market. I mean that when we ingest new data daily for in this case, one of our transaction data sets, we're trying to process that data, run it through the system, generate predictions, and publish that data out to our customers. And that's where the hours count. And it really counts to get that data through the system before the market opens on the East Coast, frankly. And that's really king, because what we've discovered through years, 15 plus years, is that our customers that leverage our data grow with us. We have almost no customer churn when our customers are actually leveraging our data. What we find, though, is that the more complex it is and the longer it takes us to get the data to our customers, that's where we get our churn. So as a CTO, one of the things I'm aiming at all the time is removing the barriers to letting our customers leverage our data. While some of our customers have large and complex and sophisticated data engineering teams and full staffs of data scientists, a lot of our customers actually don't have anywhere near that team, and I'm always driving to reduce the integration challenge on the other side. And that's actually where, Snowflake is really key in the long run, and we'll talk about that more. But then, of course, I'm also working in a company, and therefore cost reduction is part of the process as well. Because some of these things, we can throw thousands more machines from Amazon at the problem and reduce the time, but the truth is we take our profit out when we do that. I think that's always one of the goals is cost reduction, no matter what we want to say about it.
At least put another way, maybe at least as data scale grows, costs don't grow with it in the same proportion.
Or more so, right? Because that's
Or
one of the
even
things that
more so.
happens, right? It's like, well, that's geometrically going in the wrong direction. As we talk about this
Yep.
solution and what we're really trying to do, if we think about it, we bring new transactions in, and clearly this is a simplified view. We bring new transactions in to the process. I titled the center there magic. It's not magic. That's where we actually roll up our sleeves and get the dirty work done. But we bring the new transactions in, we tag them. We do other things too. We enrich the panel essentially. But then, we provide both internal and external customers the ability to do cohort analysis. And then we aggregate the panel. In all cases, this data has to be aggregated before it goes out. And then we provide some capability for normalization and sort of marry that data back in. And then we output to customers, actually both internally and externally. One of the things that we have, I have 15 internal analysts that are my customers that are very similar to our external customers as well. And what we're trying to do here, of course, is, reduce time and complexity from one end of the system to the other. From an architectural challenge, this is actually something where it's really interesting how well the Ascend capability set fits here, because our data arrives partitioned basically naturally by delivery day. And what that means is that we get data from many different transaction days delivered all on one day in a single file. But our customers don't really care when we got the data. Well, they want it fast, but they don't care, they're not doing analysis based on the day we got it. They're doing it based on the day the customer created the transaction, right? And, a delivery day contains, sort of the vast majority of a delivery day is transactions over the last 1 to 10 or so days. But we also get, when there are new accounts with backfill included, we'll get 24 months of data. We get this weird small slice of data that covers 24 months. And it really throws off all of our history a little bit on the one hand when it does that, but it also totally destroys the partitioning schema, which means that when we're really using the partitions, if we use the natural partitions that the data arrived in, we have to look at every file for, even when we're looking at 4 weeks ago's data or a year ago's data. So allowing that data to get repartitioned sort of on the fly from the file date to the natural transaction date and flowed out across the partitions is huge to us. And the thing that Ascend brings is that we don't then have to update everything, right? Because we don't get transactions for every day in the past. We get transactions for 15, 20% of the transactions in the past. And by monitoring the individual partitions and processing incrementally, that leverage is huge for us. And weirdly, it's not all about cost. It's also about the amount of time it takes to process that stuff. I talked earlier about cost reduction, but one of the things that I look at, when I'm thinking about cost, is that the most important way to reduce cost is to reduce the time that is spent doing compute. And the byproduct of that is on the one hand cost, but it also reduces the amount of time it takes to push petabytes of data through the system. And, we end up looking at those things as if we're trying to reduce cost. But what we're actually looking at is efficiency. And efficiency, I tend to try to think of that in a positive direction, not like reduce cost. But once again, you see that reduced time, By pushing out all the way through into Snowflake, though, one of the things we push, we're overusing the word push, but we leverage is Snowflake's ability for the zero data copy and just providing our customers direct access. Because one of the things you start dealing with that multi-petabytes of data, you actually copy time, even in S3, takes real amounts of time. You start talking about adding a half a day to your process when people are copying files around. And just taking that out of the mix, right, is huge. You get extra hours to work on your data because you're not delivering. You're just permissioning it essentially. And it's really huge. I think when you look at the architecture to see how much you see Snowflake in here, and I represent them as separate Snowflake databases, but the truth is, you go in and out of the same store, et cetera, and we manage that process. And we try to do that without copying the data all the way through. It's, we don't have a lot of data that changes every day. We don't process billions of new transactions every day. We process, millions of transactions a day. And by being able to do incremental updates instead of shoving out another billion records, we're able to keep it to the millions. And it's not straightforward, right? Knowing when you think about that backfill that comes in every day that spreads out over n number of months, being able to manage that and maintain the incremental nature of, what are essentially thousands of partitions is really key to the process. Tom, you want to talk a little bit about, you're the sort of Snowflake and Ascend part of this, and
Yeah,
ask me
sure.
a question here, I think.
Yeah, sure. You highlighted some of the key capabilities for sure. And kind of at a meta level here, if you didn't pick up on it, one of the things about Ascend is that we really do focus on the complete end-to-end capabilities required to build and operate data pipelines. And so Ben and our customers don't have to go out and find tools for data replication, to find tools for building transformations, to tools to do orchestration, to then deliver the data at the end. And then all the stitching of those things together. We really bring this together into one, I wouldn't even say integrated platform, because it is one singular product. And this is a very powerful notion because it enables us to do many things that these other piece part solutions can't do, which, as Ben mentioned, do incremental processing through a pipeline, not just an ingest. So just to touch on each of these capabilities just super fast. One, on the ingest side, we do allow data engineering teams to connect to anything, anywhere. And that's just a fundamental importance to any data engineering team. You can't be limited, go after. On the transformation side, we let you code in your language of choice, and it's a declarative based system as well, which, dropping down to the orchestration, means that we remove 95% of that typical orchestration code that you'd have to write to take care of so many things like incremental processing, like doing this repartitioning that Ben mentioned, from the date when it arrived to the actual transaction date itself. This data aware kind of control plane we have takes care of that for our customers. Then on the delivery side, yeah, go ahead.
I would just interject there that it really stands out as a differentiator so much, even in the world of streaming. So many things roll back to batch processing and scheduled things that get kicked off. And actually the data aware, like having the triggers built in on the partition changes is really stands out.
Yeah, and lots of other cool things that this does that don't have time in this presentation to do, but yeah, at a meta level, it really is unique. Nothing out there has this control plane that's really monitoring what's going on across the system. Then on the delivery side, as Ben mentioned, to be able to take this data and emit it to other locations, whether it's actually to a customer, whether it's to your own databases that you're serving up data for applications. You don't have to layer in some more code that is based on data landing and on a trigger, some Lambda function that will move it from point A to point B. It's all seamless and codeless really inside of the Ascend platform. So if you hit the next slide, Ben. So if we take Ascend and then we look a little bit at Snowflake as well, and this will really looking at this from a, thanks. Not mean to be a Snowflake spokesperson at all, but it is, we have a really great partnership with Snowflake, as does Ben, and there's some great reasons for that. Across our customers who are running data engineering workloads on Snowflake, it cannot emphasize enough the word simplicity. Like there is nothing to operate. It's a fantastic backbone where we can spend and our customers can spend all of their data engineering effort on really what matters, which is the code that is going to manage and massage the data itself, not on any of this infrastructure. We have no limitations on the data types, the data volumes. Snowflake is awesome at that as well. And then lastly, on the kind of the performance and reliability side, for sure, the ability for warehouses to scale, and in fact, in an Ascend world where we can assign multiple warehouses to data pipelines, you can actually take advantage on those activities that may be incredibly intensive, have a singular warehouse or a clustered warehouse that is assigned to that workload, while your other workloads are leveraging other warehouses. So just really an amazing backbone, brings such simplicity to our customers and to Ascend workloads. And if you hit the next slide, just a visualization of that.
Well, and I was just going to add in there, one of the things, I think every sort of big data, old data person has, 25 patterns that they've developed over the last N to 20 years. And what I find myself when working with Snowflake specifically is I regularly get ready to put that together and then realize that, well, they actually had that same history too. And so they built that into the product. It's hard to pull those out individually, like which one, where they are, but I run into it all the time where I get ready to implement that old pattern. And it's actually built in right from, you talked about simplicity and reducing complexity, and every one of those just makes things straightforward.
Yeah, and just to summarize that, it's a great statement, Ben, is the, I think this is part of the unique combination of Ascend when we get into these bigger, more complex workloads, is that in the combination with Snowflake, collectively, we're reducing the load on the actual data engineer. And to your point, you're saying you're trying to actually not have it be data engineering work. Because this combination abstracts so much of that kind of underlying plumbing complexity. Like you said, the patterns, we know what those patterns are, and so we can codify them. Just like Snowflake can, we can codify the lineage or incremental processing or data profiling. All of that happens automatically in Ascend, and really helps to let the data engineers, again, focus on really the high value impact stuff around what do I want done to my data.
Yeah, I think that's, data engineering so often is just getting the data to the point where you can use the data, right? And, when you're talking about it's always been that way. When we're pushing Excel files around, you still have people who are formatting the Excel. But yeah, my goal, you touched on it there, is always to reduce the complexity, right? I want people to be able to use the data right away. And that's part of this whole journey. So, when we talk about what our goals and where we've come, moving a full day from our lag. So the time between the transaction date and that transaction being leverageable in our output for our internal and external customers. So removing a full day from that, just operational overhead, and I think of this as things like where you have a process spinning and it looks every 5 minutes to see if a file has been updated, right? It sounds like you've got a trigger, but what you're actually doing is just a guess and check over and over and over again. And, moving away from that, just the operational overhead of only running the compute that's required and when it's required. And in the instant data delivery for Snowflake for the Snowflake customers. I mean, in all honesty, I try to be very agnostic. You talked about you can connect to data anywhere, and Snowflake's part of this, but one of the benefits that we think about Snowflake, all of the data is in a single system of record, which is Snowflake. But if somebody really wanted me to tap it into a stone tablet and drop it through a skylight, fine, we'd figure out how to do that, right? I don't care. And it's not my job to care. My job is to enable the customers wherever they are. And I really want people to be focused not on how to get the data. I want them to be, I don't care if they even have their own Snowflake. We'll permission them in our Snowflake. And, my real goal is that our Tableau dashboards are, in workbooks that we can allow the customers to download. They use that same OAuth credential all the way through Tableau into Snowflake. And because the data is actually complex to dashboard, right? And I would like to be able to give them our Tableau dashboards and say, load this into you. If you have Tableau, load it into your system. Connect directly into our data. I don't care, add other data, right? But I want you to know how to leverage our data immediately. That's what I'm looking ahead to. And we've come a long ways, from where we were 3 years ago with Excel and copying CSV files around and, Redshift, Aurora, Databricks. I think Greenplum was gone by the time I got here, but it was here before. Everything we do publishes into a Snowflake data warehouse. That's our system of record. We have, we're monitored and instrumented. And the next piece is to be able to allow customers to connect directly. And that's all, it's only because of these much more modern tools, right? And picking, the best solution. It's one, but boy, there are a lot of people out there selling you the one platform that can solve every problem. And I'll leave it at that. I think that leaves us about 5 minutes for questions, unless Tom has probably a follow-up.
Nope, this was great, Ben. Thank you so much for joining us. I love your story and what you all are doing there, and I hope folks got some good insight. And if not, I'm sure you can figure out how to track down Stock Ben on LinkedIn for some follow-up, and we'll stand by for some Q&A.
All right, sounds good. Thanks, Tom.